Welcome to Open Walnut, your one-stop shop for all things cyber, cloud, and automation. With our tutorials and engaging content, we'll show you how to protect resources, leverage the power of the cloud, and automate your way to success. Let's get it cracking. Hi everyone. This tutorial series will provide you with an overview of how to employ Terraform to automatically configure detective controls in your AWS environment. The controls we will be configuring through this lab are AWS Config, AWS CloudTrail, AWS Security Hub, and AWS GuardDuty. All of these services will aid you in securing your AWS environment. There will be a separate video for each of these services, therefore make sure to subscribe so you don't miss the next episode. We will begin this series with AWS Config. Prerequisites for this lab are basic knowledge of AWS and Terraform, AWS CLI and Terraform installed and configured, and lastly AWS profile configured with permissions to AWS Config, AWS CloudTrail, AWS Security Hub, and GuardDuty. AWS Config is a powerful tool that lets you record, assess, and manage resource configurations and relationships within your AWS environment, and monitor how these gradually change over time. With AWS Config, you can gain greater visibility and control over your infrastructure, streamline resource management, and identify and remediate security vulnerabilities. Additionally, AWS Config can help organizations ensure compliance with industry standards and regulations by providing detailed auditing and reporting features. Whether you're managing a small AWS deployment or a large complex infrastructure, AWS Config can help simplify your operations and improve your security posture. Employing AWS Config provides benefits to various organizational functions, such as resource administration, auditing and compliance, managing and troubleshooting configurational changes, and security analysis. AWS Config helps organizations ensure compliance with industry standards and regulations by providing a detailed inventory of their AWS resources, tracking changes made to those resources over time, and alerting users to any non-compliant resources. By providing real-time information on changes made to AWS resources, AWS Config gives organizations greater visibility and control over their AWS infrastructure. This allows them to identify and resolve issues quickly and make informed decisions about resource allocation and optimization. AWS Config also makes it easier to manage AWS resources by providing a centralized view of all resources across an organization's AWS accounts. This can help streamline resource allocation and reduce the risk of misconfigurations or duplicate resources. Lastly, AWS Config provides automated and continuous monitoring of AWS resources, which can simplify the auditing process and reduce the time and effort required to generate compliance reports. It also provides detailed configuration history of all resources, making it easier to troubleshoot issues and track changes over time. AWS Config can track many different types of resources, including compute, networking, storage, database, IAM, and many more. For the full list of resources, please follow the link below. Now let's talk about the features that AWS Config has to offer. Let's start with configuration history of resources. AWS Config maintains a complete history of changes to your AWS resource configurations over time. This feature allows you to view the current and previous configurations of your resources and understand how they have changed over time. This can help you track changes and troubleshoot issues in your environment. In addition to tracking changes to AWS resources, AWS Config also allows you to track changes to software configurations on your EC2 or on-prem servers using the AWS Systems Manager agent. This feature allows you to view the historical configuration of your software on your instances and ensure that your systems are properly configured and patched. Next, we have Resource Inventory. AWS Config maintains an inventory of all resources in your AWS environment, including their configuration details and relationships to other resources. You can use this inventory to view the current state of your resources and track changes over time. Next up, we have Rules. AWS Config rules are pre-built or custom rules that check for specific resource configurations or compliance issues. For example, you can use rules to ensure that all of your EC2 instances have specific tag, or that all of the S3 buckets are encrypted. You can also create custom rules to meet your specific compliance requirements. Change tracking is another cool feature of AWS Config. AWS Config tracks changes to your AWS resources and can send notifications when a resource or configuration changes. You can use this feature to troubleshoot issues and identify potential security risks. The last feature we're going to discuss is resource relationship tracking. AWS Config allows you to track relationships between resources in your AWS environment. This feature helps you understand the dependencies between resources, identify the impact of changes, and troubleshoot issues related to resource relationships. So, what are some of the use cases of AWS Config? AWS Config can help you with various organizational functions. First and foremost, resource administration. AWS Config provides a centralized inventory of all resources in the organization's AWS infrastructure, allowing administrators to more easily manage, track, and organize their resources. This helps reduce the risk of misconfiguration, improve resource allocation and utilization, and streamline resource provisioning. The next use case is auditing and compliance. AWS Config tracks and records all changes to resources in the organization's AWS infrastructure over time, enabling continuous monitoring and auditing of resources. This helps organizations identify and address compliance issues and enforce policies across their infrastructure. Furthermore, AWS Config can be used for managing and troubleshooting configurational changes. It can be used to identify changes made to resources over time, providing administrators with the ability to track changes, troubleshoot issues, and roll back configurations when necessary. Lastly, AWS Config is a great tool for security analysis. It can be used to identify and remediate security vulnerabilities in organizations' AWS infrastructure. By tracking changes to resources, AWS Config can help identify unauthorized changes, track access to resources, and provide alerts when changes are made to critical security configurations. Now, let's move on to components that make up the flow of AWS Config. First off, we have AWS resources, which are the actual resources that are provisioned in your account, such as EC2 instance, S3 bucket, RDS instance, and so on. The next component is configuration history. AWS Config captures the configuration of your resources at regular intervals and provides a detailed history of changes made to your resources over time. Following, we have configuration items. AWS Config captures and stores the configuration of each resource in your account as a configuration item. Configuration items include metadata such as resource type and ID, relationships, configuration details, and related events. AWS Config creates configuration item whenever a change happens to the resource that it's recording. So what does it use to capture the configuration items? Well, it's called Configuration Recorder. The recorder continuously records changes to the configuration of your resources in your AWS account. The Configuration Recorder captures the configuration details of all supported resources and stores the data in Amazon S3 bucket for easy access and retrieval. Following, we have AWS Config Snapshots. You can use snapshots to manually capture the current configuration of your resources, allowing you to track changes to resources over time and perform historical analysis. The main difference between configuration history and snapshots is that history is automatic and goes over any time period, and snapshots are manually enabled and capture point in time. The last component we are going to discuss is delivery channel. This is a configuration that specifies the delivery mechanism for configuration history and configuration snapshots. There are two main delivery channels, S3 bucket and SNS topic. S3 delivery channel sends configuration changes and snapshot data to an S3 bucket in your AWS account. S3 delivery channel is commonly used for auditing, compliance, and change management. SNS delivery channel sends notifications of configuration changes and snapshot data to an SNS topic. SNS delivery channels are commonly used for triggering alerts and notifications to other AWS services or external systems. So let's combine everything that we've discussed so far into kind of a flow and see how AWS Config actually works. When a change occurs in one of your resources, AWS Config springs into action and records the details of the change, including the resource type, name, current configuration, among other things, and normalizes them for easy reference. AWS Config then ships these normalized changes to your selected delivery channel, be it an S3 bucket or an SNS topic. While doing so, AWS Config simultaneously evaluates the recorded configuration against your desired state, as defined in your config rules. It's like having a faithful companion that always checks to make sure that you're on track. AWS Config also detects non-compliant configurations and promptly reports them as compliance issues. And finally, friends, you can view the inventory, relationships, compliance status, and configuration history of all your resources in the AWS Config dashboard. It's an effortless way to ensure compliance with your organization's security policies and monitor configuration drift over time. Now that we've finished with the theory part, let's move on to technical implementation. First of all, let's create our Terraform configuration file and insert configuration code into it. Configuration file typically consists of the required version, required provider, and backend. Now let's run Terraform init just to make sure that everything has been properly configured. This takes a few seconds, and now we know that it's been properly configured. In this video, we'll be using AWS Config to check if S3 buckets have versioning enabled. Let's start by creating example bucket.tf file, which will contain all of our bucket configuration. Next, we'll create resource AWS S3 bucket, and actually we'll create 3 different buckets. 2 of them will have versioning enabled, and 1 of them is not. The resource AWS S3 bucket consists of just 2 arguments, bucket, which is the bucket's name, and force destroy, which equals to true in order for us to be able to delete the bucket even if it has any resources in it, which in this case it won't. Another resource that will be present in this configuration is AWS S3 bucket versioning, which is the resource that actually is responsible for enabling versioning on the S3 bucket. Now that we've configured the bucket, let's actually create them for future use. Prior to creating these resources, let's run Terraform plan to ensure that what will be created is indeed what we intended. To go through the plan quick, and now that we went through the plan, let's run Terraform apply. And now all of our resources have been created. Now we can move on to actually implementing the AWS config itself. Let's start by creating configuration recorder.tf file. And there, the first block we are defining is AWS config configuration recorder. This recorder will capture configuration changes in the specified AWS resources. And in this block, we define a configuration recorder named detective controls and specify the IAM role that AWS will assume. For now, we'll leave it blank and come back to it later. This role will be responsible for accessing and recording configuration changes in AWS resources. The recorder group block is where we define what resources AWS config should monitor. In this example, we're monitoring AWS S3 buckets and the account public access setting. Following, we create an AWS config configuration recorder status resource named detective control. This resource enables the AWS config configuration recorder we defined earlier. Let's break it down. The name attribute is set to AWS config configuration recorder .detective controls.name, which references the name of our AWS config configuration recorder above. This links the status resource to the previously defined recorder. Next, we have is enabled attribute that is set to true, and that's indicating that we want to enable the configuration recorder. Once enabled, AWS config will start monitoring the specified resource and recording any configuration changes. Lastly, we have depends on, which for now we will leave blank and come back to it later when we define our config delivery channel. Next block is a data block for AWS IAM policy document. This is where we start defining the assume role policy with effect allow. The principal here would be service with identifier of config.amazonaws.com. And the only action it needs to take is the STS assume role, which lets it obviously assume the role. Next, we will define the role itself with AWS IAM role block. Within that, we have 2 arguments. The first one is assume role policy, and we'll link the data policy that we've created above, and we'll give the name my AWS role. Next, we will define another data block of IAM policy document. And here again, in the first statement, we define effect as allow, and we give it a number of actions. Most of the actions are related to config itself. However, we also include 2 S3 actions. That's S3 get wildcard and S3 list wildcard. And these actions will allow AWS config to have access
to the resources we want to monitor. The next statement is an allow statement as well. And here in the actions, we define logs create log stream and log create log group. And that statement allows us to record various events into CloudWatch. And in this case, after that, we can create alarms based on the events recorded. The last code block that we define is AWS IAM role policy. And within that, we have 3 arguments. We'll start with policy, and then we'll link the data AWS IAM policy document that we've defined above. Next, we have role, and here we define the role that we've also created earlier. And lastly, we have name, which is my AWS config policy. Now that we're finished, let's run Terraform apply. And here we get an error, which makes sense because, as I mentioned earlier, we need to come back and fill in role arm. Because when we were first creating that block, we did not create role arm. Now, actually, let's do Terraform plan because that's a way better practice to do Terraform plan first prior to actually doing Terraform apply. And now it seems like everything has planned accordingly, so let's continue on. At this point, we have finished with AWS Config Recorder, and let's move on to the delivery channel. In this segment, we will set up delivery channel. Let's first create the config delivery channel.tf file. And the delivery channel, as mentioned earlier, is essential for sending configuration snapshots and notifications about changes to Amazon S3 and Amazon SNS, respectively. So let's dive into it. First, we'll start by creating an S3 bucket that will store the configuration snapshots. In this block, we define an AWS S3 bucket resource named control storage. This bucket will be used to store the configuration snapshot that AWS config captures. Note the bucket is made out of 2 arguments. Again, we specify the name of the bucket with the bucket argument, and we put force destroy equals to true. Note, force destroy equals to true is just used on the lab. I would not recommend using it in production environment as you can accidentally destroy valuable resources. Next, we need to specify the permissions that AWS config requires to access the S3 bucket. In this code block, we define an IAM policy document named control storage using the data block. This policy document specifies the necessary permissions for AWS config to work with the S3 bucket. The first statement grants AWS config permissions to retrieve the bucket's access control list and bucket policy, which is required for delivery channel to function properly. The second statement gives AWS config permissions to put objects and object ACL in the S3 bucket. Note that both of these statements only give access to the specific S3 bucket, and we specify principal as AWS config to limit the exposure of this bucket. Also note that in the second statement, in the resources, we make resource a variable with the $, curly brackets, and quotation marks. Also at the end, we put backslash wildcard to make sure that it has access to all of the resources within the bucket. Additionally, we use a condition to ensure that only the bucket owner has full control over the bucket, adding an extra layer of security to the S3 bucket here. Now that we have defined the IAM policy document, we need to attach it to the S3 bucket. In this code block, we create an AWS S3 bucket policy resource and associate it with previously defined S3 bucket. The bucket attribute is set to the bucket we've created earlier with the ID. This ensures that the policy applies to the correct bucket. The policy attribute is set to the policy we've defined above. And this policy document contains necessary permissions for AWS Config to work with the S3 bucket. Next, we will create our SNS topic that will receive notifications about configuration changes. In this block, we define an AWS SNS topic resource named control send. This topic will be used to send notifications from AWS Config about configurational changes. And finally, now that the S3 bucket and the SNS topic are ready, let's set up our delivery channel. In the final block, we create an AWS config delivery channel resource named Detective Controls. This delivery channel is responsible for delivering configuration snapshots and changing notifications to specified S3 bucket and SNS topic. Within the block, we have S3 bucket name, SNS topic ARN, and name of the delivery channel. Here I put live delivery channel, but you can specify it to your environment. We also have snapshot delivery properties, and delivery frequency is set to every 6 hours. Lastly, this resource depends on the AWS S3 bucket, SNS topic, and configuration recorder. Now that all of this is set, we can go back to the configuration recorder and fill in the missing dependency in the status resource block. Perfect. Now that's done. Let's quickly run Terraform plan just to ensure that all of the resources have been created correctly. Let's wait for the plan to finish. And now that we don't see any errors, let's move on to creating the config rule. We'll first create a file called configrules.tf. And within that file, we will start specifying the resource AWS config rule. We will give the resource a name S3 version enabled, and the rule checks whether the versioning is enabled for the S3 bucket, as the name suggests. The name attribute is set to S3 version config rule, which is a user-defined name for the AWS config rule. For your case, choose a descriptive name to easily identify the rule's purpose. Following, we have source, which specifies that we are using an AWS managed rule, which is predefined rule provided by AWS. The source identifier is set to S3 bucket versioning enabled, which is the identifier for the rule that checks versioning is enabled for the S3 bucket. For scope, we define only the AWS S3 bucket resources. That means the rule will only check compliance for the S3 buckets. Lastly, we'll specify the depend on attribute, and this will ensure that AWS config rule waits for the detective control resource to be created before proceeding. Let's run Terraform plan again, just to ensure that we have done everything correctly. It seems that we have, and now we can do Terraform apply. Let's wait for the results to come through. Everything is successful. Click yes. Why I'm clicking yes here is because I've did this lab before, so I know that all of the resources are correct. In your case, please double check again that the plan matches before you apply. Everything has been applied correctly. Now that everything has been applied, let's head to AWS just to double check everything. Let's head to config. Within the config, let's go to settings. Here we can see our recorder and that the recording is on. In general settings, we can see the specified resource type as our strategy, and we can also see our role. In the list of recorded resource types, we can see the S3 account public access block and the S3 bucket just like we defined. And then we see our delivery method, our S3 bucket, and our SNS topic. Let's actually head to the rule itself. In the rules, we can see the S3 versioning enabled rule, and if we go there, we can see our non-compliant buckets and our compliant buckets. Everything looks good here. Let's head back to the rule. If you want to get the latest results, you can click on the rule, then go to Actions and click Reevaluate. This will reevaluate the rule and assess all of the resources again with the latest assessment. Didn't seem to work. Let's click again. However, as we head back into the rule, we see that AWS Config is currently experiencing unusually high traffic. Maybe that's why the status earlier did not switch to reevaluate. However, if we click at the time, we can see that the latest detection was about a minute ago. Let's refresh the page. And remember, we did two different evaluations, and here again we can see that the time changed to 3:33, which makes sense because we did it twice. Here everything looks good, and everything has been set up correctly. And there you have it. We've just created an AWS config rule using Terraform that checks if versioning is enabled for an S3 bucket. This is just one example of how you can use config rules and AWS config to enforce compliance and ensure best practices in your AWS environment. Using Terraform, you can easily manage and enforce AWS config rules across multiple accounts or environments, keeping your resources in check and your infrastructure secure. Well, now that we're finished with the lab, let's go ahead and destroy all of our resources. That way we don't get charged extra money for hosting them. And now all of our resources have been destroyed. In conclusion, throughout this video we've covered how to use Terraform to deploy AWS config. We went over how config works and discussed various components such as config history, config items, recorder, delivery channel, and finally config snapshots. Also, config's features were discussed, for instance, configuration history of resources and software, rules, resource inventory, change tracking, and resource relationship tracking. We've discussed numerous benefits, like streamlined auditing, enhanced visibility and control, simplified resource management, and improved security and compliance. Lastly, we've covered various use cases for config, namely resource administration, auditing and compliance, security analysis, and managing and troubleshooting configurational changes. To take your learnings further, we encourage you to explore real-world scenarios employing AWS Config and Terraform. And don't forget to subscribe to our channel for more in-depth tutorials on cloud technologies. If you have any questions or insights, feel free to share them in the comments section below.